Hello, college and teacher. I am Jorge Revalo. I am going to talk about developing a forward connect neural network to classify icons. Um, Introduction. Lately, neural networks are coming back to the present time for the archives they are archiving. For example, Google has managed to define its own reCAPTCHA with neural networks. Stanford have managed to automatically generate captions quite improvised goals and that are getting closer and closer to the original idea of reproducing the function of the human brain in a computer. Function of a neural network. Despite their name, neural networks don't have to complicate a concept behind them. The name, as you can imagine, comes from the idea of imitating the function of the neural network of living organisms. A set of neurons connect to each other and working together without there behind a specific task for each one. With experience, neurons create and reinforce certain connection to learn something that remains fixed in the usage. The basic unit of the neural network, the perceptron, the inputs are the two nodes N1 and N2, each with its corresponding weight Wn. The output NF will be 1 if it is approved and 0 if it goes code September. After giving this brief introduction, we are going to develop a forward connect neural networks. We have the download corpus that are going to develop exercise. This link, corpus download link. Corpus description, it is dataset contains various icons. Data is stored in dictionary with a case, class, style, image, rendition, and subtype. Okay. First, libraries that will be used to perform an exercise. These libraries. Then we read the data from corpus in this line. After that, when we show the first data that the corpus contains in this line, we process it, convert the image into grayscales. After that, we proceed to separate the data in training and testing. In the results, we can see that we have 19 in training and 10 in test. Neural systems are simple and perform basic mathematical functions to normalize the result between 1 and 0 or between less 1 and 1. However, they are more efficient when they are connected to each other. We convert train and test floats and then divide by 215 normalize that. Divide by 2015. Use hot encoding. The label encoding method has the advance of behind simple auto implement. However, it has a certain problem. The numerical values can be misinterpreted by some algorithms. If we have caused several critical hits with values 0, 1, 2, and 3, the strategy implemented is to create column for each value that exists in the characteristic. that we are coding, and for each record mark with and 1 the column to which the record belongs and leave the others with 0. We show in this line we show the hot encoding tests on the screen. In result is 29.
Hello, Engineer Vladimir Robles. My name is Gustavo Huelpa. I am going to introduce you to the section in which we separate the data for training and testing and how the neural network was created. For this work, we are using TensorFlow. It is a very interesting advance that what Google developed is based on n-dimension tensors and keras. Make tensor easier to use, it is a layer that is placed on TensorFlow. To divide the data, we use the train test split function. Is the simplest and most practical way that there is with sklearn. Since we pass the parameter to it, we simply call the train test split function. The size of the test is 20%. It is not longer necessary to pass the size of the training. Very important terms. Stratify. Stratify, it allows the division of the data to be most equitable. For this is considered that class than are in train one hot and random state. Important is a starter variable. All we do this preprocessing so that is quality data, so that this data when it enters the neural network there are not errors. Model 1. Creation of the neuronal network with keras. We create a model for ourselves. This model is the same as the sequential neural network. Then we add the layers. Who we add? We make model at dense, which means at the dense layer of the neurons. In this line code, we convert to a matrix of 1024 because it has a 32 by 32 entry. The function we are using is ReLU, which is a rectificative linear. In the end neuron, we use the activation function softmax that allows. Softmax converts a real vector to a vector of category probabilities. The elements of the output vector are in range 0, 1 and sum to 1. Next, this summary of the network we have. Output shape, model sequential parameters, and next we have compilation and training of the sequential network. For this make point model compile the network. Terminus important is loss, is category cross entropy, optimizer, stochastic gradient descent, and metrics. Accuracy, to know how accurate the network is. Historial, returns a trying history to me. Epoch and baptize. Remember, loss is a parameter that indicates between 0 and 1 how good we are at predicting the sample. The smaller the loss means that there is less error between the real data and the data that I am predicting with my network. Since we are using the how the coding, we use the category cross-entropy. Compute the cross-entropy loss between the labels and prediction. We save the model. Graphics. For this, we use the history variable. When I train the network, there is a training result. Matrix of confusion. The Waypoint confusion matrix based on the number of classes you have. It allows you to identify what has been grown. We see how many he classes well and how much he was grown. Ideally, make no mistake, but that does happen in real life. Precision. It is a simple way those that are classified well are added. That is the diagonal divided for the total of the points or samples. The precision show is 80%, which means that out of every 10 points that is given, it is wrong in 2 and the 8 are classified accurately. And we rep the previous steps for the author's model. We can see the model 2, we can see the model 3, and finally the best model is number 2, that is provide better precision. Thank you, teacher.